Welcome everybody. Today we are going to be talking about netcode for multiplayer games. And with us to talk about this topic, we have some incredible speakers, including, first of all, Glenn Fiedler, who has been a programmer and multiplayer lead in a lot of really incredible game studios, including Irrational, Pandemic, PlayStation, Respawn. And currently, Glenn, you are the founder and CEO of Network Next, which is, hopefully I've got this right, essentially creating a new internet for multiplayer games. Welcome, Glenn. Secondly, we have thanks. Secondly, we have Avinash Pandey, the CTO of Leela Games. Leela is best known, in my opinion, for having the handsomest CEO in the games industry, right, Avinash? Anyway,
Right.
yeah. Most recently, Avinash was working at a different multiplayer free-to-play game studio and released Mass Gun, a multiplayer shooter game that amassed over 40 million installs. And finally, we have Chris Wegman, founder and CTO of Photon Engine. Photon is the world's #1 independent networking engine and multiplayer platform. And Christoph has been working on Photon for, checking from your LinkedIn, Chris, almost 18 years now. So
Yeah.
assume you know a thing or two about this area. And it's great to have you all on with us. So I thought we could go ahead and dive right in, starting with the biggest challenges in terms from a technical perspective. Was wondering if we could talk about, what are the big technical issues that game studios will encounter as they try to develop multiplayer mobile networking games. And Chris, since you've got 18 years here, maybe we could start with you.
Sure. That's a good question, but pretty broad as well. So I could dive into like tons of different things we see. So our claim is we make multiplayer simple. So that was always what we tried to provide different techniques. So usually what we say, so the first thing, if companies approach us and ask, okay, how should I approach multiplayer? It basically boils down to what engine do you use? So the first choice is Unreal, where there's Unity, where there's probably a native engine. Then what genre are you building, right? Are you building a MOBA, first-person shooter, turn-based game, action RPG, cooperative, competitive? And then basically on top of these briefings, we help customers to decide, okay, what would be the best netcode model, and but still we see even experienced teams struggling with netcode for sure. So you have all the aspects of networked physics, right? So a game like Fall Guys, where you have 32 people playing and you have networked physics in the game, is super challenging to build, or a competitive FPS. I mean, the session is focused on mobile networking. So I think this is good to have a focus, because if you talk about, let's say, PC or console type of challenges, it's usually completely different. So so network physics, matchmaking is definitely a challenge. So if you launch your game, you have low player numbers, you need bots to integrate into your game. You need to figure out how you roll out the game globally. So where do you launch in the US, in Europe, in Asia? You need to ramp up servers everywhere. You want to have a good latency everywhere. You want to handle disconnects and reconnects. So if your game becomes popular, you have the challenges of cheating. So suddenly a lot of cheaters get into your game. So there's a lot, or a high motivation, let's say, for people to hack your game. So then, of course, you have the challenge of latency. So your game may become popular in, let's say, we just launched a game together with a partner in South America, in India, in Africa. So it's quite challenging to provide good latency in these countries, and you want to serve your customer base really well. And then what we see that the games which are launched recently and become successful are mostly driven by streamers. So streamers are a major force to make your game a success. So how do you design a game that it's actually well streamable, let's say, and is really fun to play? So we see the landscape really changing, and it's getting so professional. So it's not easy to launch a game these days and then just have a hit.
Right. And then Avinash, for you, when you were working on Mass Gun and now with this kind of new game design that we're working on, which has different kinds of requirements, what are some of the challenges that you're running into as you start to prototype some stuff?
Right. So when we talk about mobile, so there are some certain constraints which apply to not only netcode, but overall game. And when you are just starting to develop any game, you have to think about all of them. So on top of my mind, like performance and bandwidth, these are like two major limitations which you will have on your game. So whatever solution you choose, you have to keep these constraints in mind. So let's talk about performance. So whatever networking solution you use, depending on, again, I think this answer will come up in all questions, like what type of game are you building? So if you are building a MOBA where, large number of players, then the solution is going to be completely different. Like you cannot send data of all this, for example, 500 players from mobile device to the server. So you have to have plan and architecture to kind of, mitigate those kind of things. Then one of the hidden things, which from my personal experience I have seen, is bandwidth cost. So game developers don't realize this initially, like, send as much data as possible, have really high tick rate. But then once the game is live, you have whatever CCU, 1,000, 2,000, 20,000 or million CCU, then this factor starts kicking in. And sometimes it might also happen that you might end up paying more for bandwidth than actually the server cost. Right. So you have to make sure that you optimize whatever data you send on the wire and how much data is required. So if, for example, you are building a shooter game of 100 players, for example, Battle Royale, then you are only interested in players who are in your interest area. So you only send data of those players from server and from the device as well. So I think these are the top things. And the other thing, I think, for mobile games, which is one of the attributes of deciding whatever solution you are going to choose, is cost. So multiplayer is not only about netcode, but there are other services which you are going to use. So you will need API, you will need database, and then it is not that hard to kind of extrapolate some of these numbers. So if your game has 20 player count, then you can just build some prototype, see how much data you are transmitting for one player, what kind of server you need, and then calculate netcode cost, server infrastructure cost, database cost, API cost, and calculate everything and see whether this makes sense for your game or not. So I think these are some of the challenges which I will add on top of what Christoph talked about.
Got it. And Glenn, for you, and by the way, since you're actually taking more of an approach in terms of trying to actually fix the network, does that suggest that some of the solutions from a client perspective are intractable to some degree? Or maybe you could talk a little bit about that as well.
Sure. So I don't want to dive right into the network next thing, because I do think it's something you experience right at the end of the journey of all the things that Chris and Avinash mentioned. Let me start by basically saying, like, look, when you're making a multiplayer game as an engineer, what is your job? As a network programmer, you've got to find a way for your team to be able to write networked game code, right? So Christoph, that's particularly a great fit for Photon Quantum, because it basically networks itself with a deterministic lockstep model. So that's really, really powerful. But then if you have teams coming out and saying, I want to make an MMO, or I want to make an FPS, a top-tier FPS with a high player count, I'm not sure that there's actually an off-the-shelf solution right now for those sort of games that is at the top tier of what I've experienced working at AAA studios, who in many circumstances like Respawn, these folks had been shipping these games all the way back for 15, 20 years. So it's sort of like the sort of code bases that these games have and the networking approaches. I don't see a turnkey product out there that does this well. Not even Unreal, for example. The way that Call of Duty is networked is quite different to the Unreal network model. So, but let's sort of go past the real hard part, which you should think of when I want to network a game, which is, what's my network model and how do I make my gameplay engineers productive, right? When you launch it, you've got this really interesting challenge, which is, where do I host my servers and what provider do I host them with and what's it going to cost? And And there's a really interesting thing here. You can try to host servers everywhere, right? And what happens is that you actually end up fragmenting your player base. And it's really challenging because when you launch a small game, you actually don't want that fragmentation. The whole point of a multiplayer game is for people to play together, right? So there's an interesting trend that I've seen over the last 10 years where larger games are setting up regional play and trying to get connectivity to that central area for that region really good. And that's probably best demonstrated by Riot with Riot Direct, because Riot created League of Legends and realized that the internet performance wasn't good enough for their game. They basically built their own private intranet, and League of Legends is hosted for North America entirely out of Chicago, right? There's no East Coast, West Coast servers. They did originally try that, and then they consolidated centrally. So the tension that I see when you launch a game is like, where do I host? How many places do I host? Do I try to get my game close to everybody? Do I try to go central? And how do I make sure that people can play quickly together? And then if you get really popular, it turns into how do we do skill-based matching and make sure that people can play together at a similar skill level? But there's this tension between hosting in many different places and hosting in few against fragmentation. This is why some of these MOBA games are very popular, because, 10 years ago, player bases would be fragmented by, I'm playing one of 5 different game modes, right? So like you couldn't play, an esoteric game mode on PC at Tuesday at, 2 p.m. because no one else was playing it near you. So you might notice that many games now have only one map, right? And only one game mode. So there's this interesting trend towards trying to make everyone play together and to reduce fragmentation. And then the natural extension of that is host in fewer locations, but have better connectivity to those locations. So that's what we're doing in Network Next.
Got it. So Glenn, if I'm understanding you correctly, I think what I'm hearing you say is that for a game studio to provide a great multiplayer experience, there's one way to think about it is on the netcode side, and there's different approaches, whether it's, client lockstep or kind of MMO type of model, but then there's also like a network approach. And so from the perspective of the network, how you manage that, it will also factor in. But in terms of like, if we could focus on that netcode part, I was wondering if we could talk about what are the primary approaches in terms of all the different types of ways that you could attack netcode. So, client, lockstep, server, MMO. And Chris, maybe you could talk about Quantum's approach and maybe your thinking in terms of what the major types of approaches are.
Yeah, sure. So when we started back in 2003 and in the past 10 years in particular, where we focused on real-time multiplayer, we started, let's say, with the classic approach of synchronizing game state, which is, let's say, the most common sense approach, where you say, okay, you have whatever V4 are playing and you are exchanging positions and velocity and rotation, and you synchronize that continuously. And then you have to make sure that all the clients are kind of seeing the same thing and do a good job there, or you let a server do the work, which is synchronizing the clients at some extent. So which is still the major model what companies are doing. And then about 4 years ago, we started to investigate into predict rollback networking, which is only synchronizing input. So it looks like all the controllers are attached to your local machine. So you're not synchronizing anything inside your simulation, but only the input. And this is revolutionary in the sense of that, as Glenn mentioned, so there's no netcode anymore. So from a developer perspective, it simply doesn't exist. It looks like everything is local. And it sounded too good to be true. It still does. But it's quite fascinating how well it works. Of course, there's a catch. So this approach has limitations, and you couldn't build a Fortnite with it or an MMO. So it's limited in terms of players, which is the major limitation of that approach. But we believe that for a lot of genres and game types, it's the best possible approach because it takes away a lot of the pain you usually have. So this is, again, you have to check, okay, what are you building? Is this, what is the best netcode strategy? So yeah, basically you can divide the whole networking world into synchronizing game state and synchronizing input from top. And then synchronizing game state is still very popular, and it's not going away, especially if you have games with more than 50 players. And that's another trend we see is the number of people playing together are getting bigger, right? So we have customers asking, oh, we all want to do a battle royale with more than whatever 50 people. So it should be 100, 200. Probably Fortnite would like to, I mean, there's a reason why their games are limited to whatever 100 players. I would like to get it as large as possible because at certain scale. But certain game types are just fine, right? You wouldn't play pool with 100 people. That doesn't make any sense, or soccer. So yeah, so these are basically the different approaches.
Right. And Avinash and Glenn, would you agree with that characterization in terms of the different approaches?
So I think when you are thinking about netcode, the mental model behind choosing netcode should be what kind of game you are building. So you should definitely think from what is your core gameplay mechanism and what kind of feel you are going to give to your users. So for example, if you are building 8-ball pool, then the choice is very obvious. You cannot build 8-ball pool with traditional approach. You have to have deterministic physics on the client. Like you cannot sync every boss position every frame. You need some kind of simulation on the client where you're just taking player input, some force, and then the entire thing is simulated in the same way on every other client. But if you take an example of shooters, I have seen shooter games which work on client authoritative, where the gameplay doesn't worry too much about cheating. Or sometimes if player get shot behind the wall, they are like, okay, I'll respawn and I'll play again. So what kind of game you are building, think about that and then choose the solution. So if cheating is a critical problem for your game, then you have to go with authoritative physics on the server. Or if player count is limited, then you can go with deterministic approach, what quantum is built upon. So I would say like the choice of netcode or engine should be from gameplay and mechanic, the field point of view, rather than finding a good solution then trying to fit it in the gameplay.
I have an interesting point of view on this one. So I've actually worked on peer-to-peer open world games like Mercenaries 2, did the networking for that, and then I went and networked God of War, and then I went and joined Respawn and got schooled basically on how they've been networking Call of Duty and so on for 10 or 15 years and learned a lot of best practices there. And one of the things I learned from that is I'm never doing peer-to-peer ever again. Right, but that's still like old news, 10 years old news now at this point. So let me kind of outline how I think of the problem space. And what's really interesting about it, I think, is that it's hard to see it at first, but it's actually a series of different, it's a continuum across a few different axes. So there's actually a lot of similarity, Christoph, between the rollback with GGPO and Photon Quantum and how FPS games like Call of Duty do rollback, although they think of it very differently, right? And they don't require complete determinism, but they're very similar elements. So here's how I think about networking. Look, the main thing you're really going to want to decide is, does the game run everywhere? And I'm trying to have it in sync. So like, if there are 16 players, the whole game is running everywhere and all 16 players are somehow in sync. Option A, right? And option B, does the game really kind of run on the server, but each player kind of sees something that makes them think that they're there? And this is the major divider, right? So an example. So I'm playing a fighting game of 4 players, right? And maybe it's GGPO style networking. which Christoph, I think it's fair to say is basically a similar strategy to Photon, right? So deterministic, and then there's rollback to high latency and all the good stuff, okay? But what's really happening is that you're really trying to have the same exact simulation run out on 4 different machines. And the limitations of this is that if you want to have a world that's larger than what any of these 4 players see, or is computationally very expensive, you can't really do that, because on the mobile phone, you can't simulate that whole open world that's like 10 kilometers wide. Even if you only see a tiny part of it, the whole game has to run on every device, right? So that's option A, right? And option B is kind of like, look, clients are just kind of viewing a ghost of the world or a subpart of it or a section, and the real game lives on the server. And this is really the divide, and it's the way to think about it. Am I having the game run everywhere, or is there really just, do I think in my mind, the server is the game and I'm just a client in it? Like, kind of like that thing with, like, you know, I'm touching the I know all about the elephant's tail, and someone else knows about the elephant's nose, right? But you don't, the 2 people don't know the whole elephant, right? A deterministic lockstep model is kind of like, no, you get the whole elephant all the time or it doesn't work. But a more classical FPS, and I'm going to go out on a limb and say, you know, MMOs must also do this, although I don't have any direct experience with MMOs. It's about having a really large world on the server, and then the client has some sort of relevancy, and they see a subset of it as they move through the world.
For someone like myself, the simple view, like more from a business perspective, that I think about when I think about these different approaches is that, one, just trying to understand the trade-offs. And it sounds like from what we're talking about, the trade-offs are really about player count, potentially also, Glenn, to your point about having to run different instances on the client. You know, so you're running CPU, does that have an impact on lower end devices, for example, if we're going with the client kind of deterministic approach? And then also from a server cost perspective, something that you mentioned, Avinash, if we're running with more of the photon quantum approach, then certainly server costs would be lower because we're running a lot on the client relative to server. And so when I think of, I mean, the other way to think about this is more from a market perspective, right? In terms of the 2 biggest genres of games, MOBAs and shooters, right? And MOBAs are the #1 monetizing category, at least because of Honor of Kings in China. But it would seem like for a MOBA, more of the photon quantum approach would be superior because there's a lot of engagement, a lot of gameplay, extremely high server costs probably. And then on the shooter side, if you're going battle royale, high player count, wanting to have broader penetration across lots of devices, then I would assume more of this server authoritative model would make the most sense. Is that a fair representation of, or is that a fair way of thinking about the different approaches?
I could give a concrete example.
Yeah, please.
Do you remember Titanfall 1 when it came out? Like
Vaguely.
the original Respawn game with the giant mechs and
Yeah.
you know what we did on the consoles? Render.
Okay.
Because the whole game ran on the server,
Okay.
right? So what the server-side thing did in that case, even though the server costs were very expensive, is it allowed us to spend a lot of time on the Xbox console and the PlayStation console purely on rendering, right? All the AI logic and the level scripting and everything while you're playing multiplayer in Titanfall 1 was running on a dedicated server somewhere. So actually, it's interesting that you can kind of choose where you want to do the work, right? But when you view games like Call of Duty and, you know, those sort of first-person shooters, if you do those right, almost the entirety of the simulation and everything is running on the server. You might only be running simulation for your own character and your shooting, and everything else is server-side. And Christoph, that's quite different to the lockstep model where everything's running on all of the peers.
Yeah, I mean, you combine it, right? So you don't want it's not the extreme case where everything is running on the server. So this is more the game streaming mode, like Stadia or the other, whatever Hatch on the mobile side of things, where everything is running. You send the input to the server is simulating, you're sending the state back. So you, as you said already, so you have this smart combination, right? So everything you do locally, you try to predict in your local bubble and be smart about it. So it feels snappy because FPS, competitive FPS players do not accept lag. So they want everything instant, right? And then you have the other challenge of favor the shooter, right? So I see Len sneaking off a corner. I'm shooting him, right, with a sniper rifle, and I want to hit him because I saw him on my screen, and you need to hit him. So, but in reality, probably Len already is not there anymore, right? So you have to make these decisions and say, okay, I saw him, so you hit him in the head, right, for example. Or but this is mostly, let's say, on the PC side of things, where it's like super sophisticated, and you have where Glenn worked. I mean, these teams are the best of the world, right? So on mobile, it's different type of teams. I mean, these studios are coming to mobile for sure, and you have the supercells, but looking at the mobile network titles, like the successful ones are slowly getting into this competitive hardcore genre. So whatever Supercell inventing the Clash genre, right, which was the first big real-time multiplayer hit in the #1 or top 10 charts. FPSs are, since we exist on mobile, super successful. I would say most of the successful games running on our cloud are probably FPS built by really small teams, and they are far from having this professional, competitive, let's say, experience compared to a PC game. But yeah, totally, it's you have to make a lot of choices, and we see people are very confused, let's say, making a decision between all the different choices. And the thing is, they ask, okay, what should I choose? And you say, well, you know, you can do everything. It just everything has pros and cons. So it depends on your team mostly, on the skills.
Yeah, so maybe we can talk about that. I know, Avinash, you've been looking at a lot of third-party solutions out there that provide various types of netcode solutions, and obviously I know you're a big fan of Photon Quantum as well, but could you talk about kind of what's out there? And then after that, it'd be great to hear from Chris and Glenn. Maybe you guys could also talk about, okay, yeah, there are kind of third-party solutions out there, then the decision between external versus building all the netcode internally. It'd be great to hear from you guys about what that effort would actually involve. But maybe starting with you, Avinash, on what's out there.
Right. I mean, there's no one perfect answer for this question, because it depends on so many factors. So it depends on what stage your studio is in. Like, what's your runway? How big is your team? What is your talent pool? And then again, as I'm just reiterating on the same fact, like, you should think from your game's point of view, like what kind of game you are building, what's the core feel you want to give to players.
Sure.
So all these factors are really important when you are deciding on these solutions. So if you are going with Unity on Unreal, these choices differ a bit. So Unity kind of deprecated their old networking solutions. So there are some apart from Photon, and when we say Photon itself is like multiple products in itself. So there is Photon Real Time, Photon Quantum, Photon Bolt. So all these libraries, they are built for different type of games. So you have to be really sure about what type of solution you need based on your game. Apart from that, there are some open source solutions like Dark Rift, Mirror, which people talk about. But when you are going with any solution, you have to always know what's the ecosystem around it. So if tomorrow you get stuck, so on high level, all these solutions would work. Like, when you are evaluating any multiplayer solution, you would want to send some data, some player data. I want to do authoritative movement. What does it mean? Like, you send some data to server sends data back to your device. And if you're testing in your local scenario, it would work perfectly. So you have to make sure that you simulate these things in a real world scenario. So if it's a mobile game and you think that you are going to soft launch in Asian countries, so, host some server in Asia. If you are using Photon, then, take Asia region. Then if it is a 20-player game, then come up with a way where you can actually simulate with 20 players, whether those are AIs or you have 20 devices or some sort of simulation. And then, evaluate all of these things, because when your game is going to go out in the live, then you are going to face lots of challenges which you would not imagine right now. Like people play from weird locations with weird network, lots of server hops. So you might optimize your game for 100 millisecond ping, and you are imagining worst case we could go like 150 millisecond. But you would be surprised by seeing people play at 500 millisecond or even to second ping. So you have to be ready for that. Whether you support those kind of pings, what's the user experience? Like, do you just let players jitter, do those spring rollbacks? So I think all these things you have to evaluate when you are evaluating networking solution.
Okay. And Chris, maybe you could speak about if we were trying to think about using photon quantum versus trying to build that internally, does that take us 18 years, or what kind of, how do you estimate the effort to build something like you guys are providing?
So of course you can always, let's say you have to make this build or buy decision. With Quantum, it took us 4 years, and we have some really, really smart guys building it in the past 4 years. So I would say that it takes that time. Usually it takes 2 years to build a version of something, right? And then it takes another 2 years to build the second version, and then you are really embarrassed about the first version you launched, basically. So this is usually the case. And with Quantum, we took a different approach, and we are charging like an access fee of $1,000 a month, which is very unusual. So it makes Quantum not available for a lot of companies because it's too expensive for them, especially independent teams. But we were able to convince some really big customers, about 70 teams using Quantum. So why? Because they made that decision that, let's say, they can't build it in-house and they need it now. So usually you have a mission, you have a project, and then you want to have something now to build it. We don't have a chance to convince EA or Supercell or Riot Games to use Quantum, most likely. Maybe if they have a little prototype team, maybe we get into prototypes, right? So but for everyone else, it's even Ubisoft, Square Enix, and these type of companies are definitely looking for a solution right now. And this is, so we are, with the product, you always have to be at the right time at the right place. So like Glenn is, I think we talk about latency a bit later and how you enhance this. I think this is a time now because multiplayer is becoming big, and there are like Fall Guys is a great example. Within 1 day, 1 million downloads, right? Or Phasmophobia, another hit by just one guy in the UK who built this, running on Photon. So becoming the biggest customer in just a week or so. And then, or Among Us, right? It's a single guy from Brazil building this game, which is #1 everywhere. And then if you build this yourself and have to scale everything yourself, that's a tough job. So it's good to have good partners for sure.
And Glenn, and maybe you could also speak to, is there a difference if you were trying to go with the more client-based approach versus server MMO-based approach?
Yeah, so look, even if you were to take excellent open source software, which there's a lot out there, and I've written some of it, and people come to me like, should we use Netcode for this or whatever? And I'm like, yeah, do you have 5 years? Right? Because you see, the hard part isn't a client-server protocol. The hard part isn't sending messages between a client and a server. The hard part is working out, how do I network my game code, right? So Christoph, your product solves that very neatly in the areas where it applies, right? Where it's challenging is when people want to make an MMO or they want to make an FPS. There isn't that turnkey product out there, at least not that I'm aware of, right? At the same level of quality. And my advice to these people generally is, used to consult in this space a lot 5 years ago. It's like most of what I did was telling people just how much work they were signing up for if they chose to build it themselves. And generally, the only team where I would kind of suggest this might make sense would be like, this is a core competency of us. Like maybe a team that has its own, they've been doing single player for a while, they want to do multiplayer, and they have their own custom engine they've been working on for 20 years, right? In that circumstance, perhaps building and designing it yourself might make sense, right? Yeah. Almost no other circumstance. Like, let's take the Call of Duty team, right? They worked on Medal of Honor, then they went and worked on Call of Duty and then Modern Warfare, right? And then they all got pissed off at Activision, right? And then they started Respawn, and then 5 years later, they made Titanfall when it launched, and I got to help out right at the end, right? And you know what they did the whole time? They used the source engine for Titanfall. They didn't even write their own engine. I mean, this is a world-class top tier. You just can't do it in the time you need to do it to ship your game if you try to do everything. So it's really, really, really difficult making multiplayer games. So if there's a turnkey solution out there that is going to let you use something and get to the important part, which is making the game and shipping the product, right? Rather than 5 years noodling around with reliable UDP protocols, right? That's the important part. And even if I was on a team, even if I created a studio, I would probably even hesitate to like go, you should use my netcode, right? Because I would need 2 years to like get all the stuff in place, and it would have to be a run rate of the studio where it's like, okay, we have 2 to 3 years just to prototype and get this done, and we might have a game out in 4 or 5 years, right? And I'm world class at this, right? It's like it's gonna take time. Right. The hardest feeling as a network programmer is being the bottleneck on the whole team. You have to have all this stuff finished before they can network the game code. Right. And you want to get to that networking the game code day one, right? So if your product doesn't fit within the turnkey stuff that's out there, maybe your best choice is to make it fit it.
And maybe speaking to the challenges, like one of the things I hear a lot about is from, let's say, some of the bigger framework providers like Unity. And one of the things I hear, and I'm more of the business guy, not the technical guy, but I just keep hearing that the netcode in Unity is so bad. And I think they restarted stuff over there. But in terms of like what's available from Unity and from Epic's Unreal Engine, could you guys talk about what is there as far as like the netcode support or the capabilities there?
Can I just give a bit of an overview on Unity?
Yeah.
There's something I really like about Unity, actually, which is that Unity is less of a framework. You can use the parts of it that you really want to use and not the parts that you don't. And that's actually something I really respect. So the problem is that networking is a structure. It is a framework. You have to do things certain ways, right? But there's no one framework that works for all type of games. So I think Unity's actually realized this and going on from their component system that they're doing and all the good work to make it modular. I think Unity is personally a superior solution. But you can take the Unreal Engine networking code and I mean, it's all there, it's shipped games, there's nothing wrong with that, but it's rather inflexible. And you can't take all of it, right? So that's the major difference. But I will also bring up that the way that Quake-derived games network, like Call of Duty and these best practice games, is quite different to how Unreal Engine is networked. So maybe that's better described as a flavor of FPS networking, but I don't actually think the Unreal Engine networking approach is actually the best one for an FPS type game even. But this is sort of getting into like wonk territory.
Chris, do you have any thoughts on what's there in Unity or Unreal?
Yes. So Unity is an amazing ecosystem. So what they did is they do a lot of things not perfectly. Whatever it was initially the UI stuff, right? It was instantly fixed by someone in the community or in the ecosystem building it. And it's not considered competition. And the same is what we did 10 years ago. We were one of the first networking solutions in the asset store back then, right? Where Unity was pretty small as a company. And they always supported us. And once they started to build something, they reached out to us and said, hey, we are going to build a competing product, just that we respect your work, we respect everything you did, and you're part of Unity. But we feel we need networking in-house. So, and they did this a couple of times. So luckily for us, there's nothing ready yet, right? So it's good for us, so we can grow. But in the end, it's not a competition, or we are in a fight. So we are in very good terms. So that's what I like about Unity. So I cannot talk too much about Unreal because we have a couple of customers using Unreal, but most top-notch games use the in-house engine. It's like Windows Internet Explorer, basically the default solution. You use it no matter if it's a turn-based game or anything. A lot of companies just use it, blueprints, drag and drop. But yeah, I think there's a lot of space in the Unreal world, but as Glenn said, it's quite complicated, right, to understand Unreal. So to get into Unity is much simpler. You can just grab the stuff you need. You have this ecosystem. You can mix and match. Of course, there's a lot of things to complain about bugs that never get fixed, right? You can endlessly complain, but all in all, it's an amazing solution. And I think both solutions have their space, and because of the competition of Unreal and Unity, we are seeing all the good things, right? Because both companies are totally motivated to build the best engine on the planet. And this is benefiting our basically all the developers, including us. So, but Unity has the healthier ecosystem because it's a much larger base of developers. And you can monetize, right? Alone in the asset store, you probably earn a couple of million a year if you are in the top sellers. It's not enough to run a big company, right? You need a subscription business, what we've built up, or services, because the asset store doesn't allow this yet. But yeah, they hire very smart people. So, and for me, it's just a matter of time if you hire like very smart people that at some point they will have a proper transport layer and relay server. But we try, and as a small, very fast chip, we try to be ahead, right? So we try to be already in the next stage. So we believe the time of building a relay and a transport layer, that's kind of boring. Everybody's doing it, Amazon, Azure, including Unity, right? It's a commodity basically very soon. We have that since 10 years. So we are trying to build templates. We believe that you want to give developers a MOBA template rather than telling them how to build a MOBA, right? It's like Amazon was developing from giving you machines to, oh yeah, there's a database. And I think now we are entering the era where you help developers with actually giving them what they are looking for. Oh, you're building a competitive FPS. Here's a template for you, which is exactly what you're looking for, right? Or a MOBA, or even a turn-based game. I think turn-based games are not going away, and they are not bad, right? You can earn a fortune with 8-Ball Pool, or having the first Fall Guys mobile, or yeah.
And Glenn, since you're kind of, I would say that given where you are in the market, you're kind of neutral. If you were to give Unity advice on what they should do in terms of Netcode, to just like forget about it and rely on, folks like Chris, or to try and build something internally, what advice would you give Unity with respect to Netcode?
Ooh. I've actually given this advice in person.
Oh, yeah. Okay.
Look, I'm kind of torn here because you see what I love about Unity is that it's flexible and it doesn't sign you up for a structure that you don't necessarily want to use. So I actually think that I'm not sure if you can actually network Unity while having Unity remain Unity. Because what I like about Unity is I take the bits that I like and I've got an editor and a renderer and and off I go, and I'll run my own dedicated server somewhere, and and I love that. I chafe with my experience in networking. I don't want to do things that I don't want to network things the way that Unreal Engine does. And if I was to use Unreal Engine, I would, and I have. I would rewrite the whole networking day one. It would take 3 years, and then that's why I'm not working on that, right? But I love the fact that it's actually wide open on Unity, and products like Photon Quantum can come in and meet a need. I like the modular nature of it, and my fear is that you might have to create a little bit too much structure to create a useful networking template. It might be kind of philosophically and culturally opposed to how Unity works, right? So my advice would actually be lean into your strengths and continue making everything modular and foster a community that will solve problems in different ways and surface the best. I think the things that Unity are doing with the component system and the core and making everything open source and more modularity and more flexibility is the way to go, and less frameworks, right? So I would almost say just don't.
Okay.
Just don't.
Yeah, services are too tempting, right? So you earn a lot of money with it.
Well,
and public traded companies are driven by monetizing everything and growing.
Yeah. So Unity did acquire Multiplay, and Multiplay do hosting, and that's an interesting play, and somewhat adjacent to the idea of building a framework for Netcode, right? And I think that was a good acquisition, and that's a good team. And clearly providing hosting services around the world is of value, right? So that's good. But I would kind of be sad if I had to wake up and kind of be like, I'm using Unity, I have to network it this particular way, right? There's the Unity framework, because I know that there's just so many different flavors of how you can network things, right? And it would be almost impossible to express all of them in a single solution.
Right.
And Unity is very much a company that tries to kind of make a product that can do everything for everybody.
Right.
Do you see? So it's almost the impossible problem. So I don't fault them at all for not having a solution. I think it's actually true to their values, and they should probably provide good low-level solutions and modular components and lean into what makes them, in my opinion, better than the Unreal Engine, and avoid the temptation to try to create additional structure that may or may not in the end be the correct structure for the top-tier games, right? Or the indie games, because it's probably different. Right.
So Glenn, speaking about that in terms of having different solutions for different kinds of problems, maybe you guys could check me on my very simple basic understanding of, for a small studio, what would be like the best in class approach, again, for a small studio. And it sounds like if you're going to be making a Supercell type of game, like a Clash of Clans, Clash Royale, or a MOBA, then something like a Unity plus Photon Quantum would potentially be a best-in-class solution. If you're going to do a battle royale-based FPS, then maybe actually just jumping over to Unreal and using the Unity networking would be best-in-class. And then if you're doing an MMO, then maybe something like a Smart Fox. I don't know. And Avinash, please check me. Would that be a kind of high-level, very basic understanding of different solutions for different types of problems?
I think my take on this is not to scare off the audience. If they want to make a multiplayer game, they have to spend like 2 years before writing any line of code. I think be very specific about what you are trying to build and just choose one solution, whatever fits right to your type of gameplay which you are building, and then try to make a prototype which can simulate the type of gameplay you want to have as close as possible. So like, sometimes, Unity is very flexible, very open. If you want to go with dedicated server solutions, you can create a headless build. But your networking is going to run inside the engine. So you have to be aware of the limitations of engine. Like, if Unity cannot support more than 100 players as an engine, then you have that hard limit. But does your game need more than 100 players? No, like your game is like, it just needs 20 players. So that's a good solution. In terms of low-level networking, there are some open source libraries. Even Glenn has written some libraries. So just choose one, whatever works best, whether it's Quantum, Bolt, Photon real time. Then just implement what you need and see whether it works. Create a playable. If you're building a mobile game, I think it's very important that you do all these testings on a mobile device. So you create a playable, test in different environments. All these tools, I think, come up with their own testing environments. So like, you can simulate lag, you can simulate drop, and also go out. Like, I always suggest developers always keep one build in your pocket. If you are in a mall, just play there. If you are in a taxi, just play there. If you are in Uber, just play your game, just play your prototype and see whether it works. Because, you have to at then understand if this game goes live on a hand of a player, how would they feel? If they're feeling right, that's the solution for you. So I think that would be the way to go in this sense.
Got it.
Can I
go ahead, Glenn.
So, Avinash, you touched on a really interesting point. You got to play your game. You got to play your game, and you don't play it on the LAN. You're fooling yourself, right? So the best practice. So one of the best practices that I learned from the Respawn folks is, people might not be aware of this, but when you're playing Titanfall 2 single player, you're playing a client and server in the same process, and they're networking. Titanfall 2 single player is a networked game. Huh? Right? Because there's this really bad pattern that I've seen, which is single player works, but then multiplayer doesn't. This often comes out for teams that have a single player background, and then the idea is kind of like, yeah, the network programmer they'll network it, right? No, that doesn't work because the network programmer is like walking behind gameplay with a little poop scooper, networking little bits, right? And that never works, right? So the real goal here is to empower gameplay to network their own code, and then they test it, right? So what better way to test that networking works is if the single player game doesn't work unless it does, right? So that's kind of sounds a little crazy, but that's how the Call of Duty folks make sure that they're single player and they're at least on Titanfall 1 and 2. There was never a situation of like, this code works in single player, but it doesn't work in multiplayer because they're the same thing. And if you can do that, that's really good. And then the next thing is always play test with simulated latency and packet loss, always, right? You never want to fool yourself, right? So I would generally suggest adding at least 50 to 75 milliseconds of latency would be like kind of a ballpark. You really don't have to go crazy and add like, 255. It's like an anti-pattern to kind of think like, what if lag's 500 milliseconds or more? It's like, yeah, you got other problems, right? Like you got other problems. The answer to that is you show a bad performance network icon at the top of the screen. That's the answer. It's not really your fault. But like the average, sort of like 10 to 100 milliseconds of latency that you'll kind of see for the good case. There's a lot of effort to be done on gameplay systems, on design, making sure that things feel good under those situations. So one of the most important things that you can do while you're developing a game and creating netcode is playing it under real world conditions. And for a mobile, that might mean playing it on a train while you go under a tunnel.
Right.
And thinking about what that means on your game design. See, some of these hard problems, they're actually not solvable from engineering. Right. They're design problems. Right? Like what sort of game should we make on a device that can go into a tunnel and disappear for 30 seconds?
Right.
Right?
Yeah, and speaking to that, the other thing that we mentioned earlier is server cost, right? And so I think that's one of the key challenges for like a MOBA. And I think what we've seen is that in high ARPU countries like China, where you can absorb all of the engagement, thus paying for the server operating cost. One of the things I really worry about, and one of the advantages of quantum, Chris, would be that if you are, more client deterministic, then maybe you can reduce your server operating costs as a percentage of net revenue from like 30% to 10% or something like that. And so, and I think that's been part of the problem with MOBAs in the West, right? Because the ARPU curves for a Western audience or other audiences is just not high enough to offset the server operating cost. But maybe that can also lead to this next question that I have for you, Glenn. So talking about the other side. So we talked about the netcode approaches. You also mentioned in terms of also kind of trying to solve from the network side. Could we talk about network next and, or any like new infrastructure on the network side, whether it's 5G or what you're building, how will that impact, sort of the multiplayer experience or netcode?
So here's the sort of critical thing everyone needs to internalize when you're making a multiplayer game. The internet doesn't care about your game. Doesn't care, right? Makes no guarantees, kind of says like whatever, right? It's not really okay, right? It's not really okay. We all work so hard on making these experiences and livelihoods and everything is behind it. And obviously we also want our players to have the best experience they can. So I created Network Next because after like 20 years of doing this, I was like kind of pissed off that like no matter what I did from the netcode point of view or the server hosting point of view, a significant percentage of players will still have a bad experience from one time. And it wouldn't even be the same people each day. It was just like this big whack-a-mole thing going on. You can't write you can't make your netcode better. Doesn't get there's nothing that I, a network engineering expert, can do to solve this problem because the problem isn't actually my netcode. The problem's the internet, right? So I started looking into it and I realized like we started measuring and we started working with partner companies who integrated our SDK and we started getting real data. And we started to find that fairly consistently 10 to 25% of a player base are getting network performance that's like easily fixed. Like I'm talking like 20 millisecond reductions in latency or ridiculous packet loss that there's no reason for it to occur, but it's just that the internet is routing them a particular way. And it's not malicious, it's just kind of like whatever, right? Like it doesn't make a guarantee. But for the sort of applications that we're all creating, that's not really okay. So what we do at Network Next is we have an SDK that integrates in the client and the server, and it just watches all of your players. And when they're getting a bad route, we find another way. And behind all of it is a marketplace where all these private networks are kind of effectively competing to carry your traffic. If they have a lower latency route or a route with low packet loss from where your player is to where your server is, wherever you host, we'll find that every 10 seconds for your player and get a good price without having you locked into a single vendor. So that's pretty much what we do. And the results are like kind of ludicrous. Can I just share my screen?
Yeah, please.
Like this is what we see, and these are all players. And if I can these are all players that are getting improvements versus the default public internet routing, and it's everywhere. But like are there bigger improvements in Africa and South America? Yes. Are there bigger improvements in the Middle East? Yes. But then you find weird stuff like at a certain time of day, someone on Google Fiber gets a big latency reduction taking Network Next to a Google data center. What? Right? The internet just has this like weird weather, right? So like, it's just weird. But like 5 or 10% of your players are probably getting pretty bad experience at any point in time, no matter where you host your servers, no matter where they are. And it's not the same people from one day to the next, right? And here are the sort of improvements that we see. Like we see like this is ludicrous, right? Now, of course, this is the best one on right now, okay? And they're in a remote island in the Pacific, sure, right? But like these other.
He's happy.
He's definitely doing better. So it's it's really gratifying to spend so much time working on Netcode and then kind of realizing, okay, I've done everything that I can, but something else needs to happen to make sure that my players get a good experience. So that's pretty much at Networkers. I'm really happy because these people have done all this work to make their game as good as they can, and then they launch it, and then we get to hop on and actually catch the 5 or 10% of the players that need real help and make the experience better for them. And people just don't realize how bad it is out there. They see this and they're kind of surprised. Wait, there are people with 100 milliseconds additional latency that you can just fix? Yeah, happens all the time.
Yeah, as a player, being the laggy person on a game, I've seen that myself. So, yeah.
And it's transparent, so you just add it to your game, right? So it's, of course, it's work, but it's just something you just patch into your game, and you have a better experience for whatever 10% of your players, or even 5%.
Yeah. Well, some of our customers even tune it that half of their players are being accelerated. Some customers with more professional player bases, because one of the things that we do is, depending on the type of game, right? Well, the question really is, what's meaningful for you? What makes sense with your ARPU curve, right? Like if it makes sense for your players to save 2 to 3 milliseconds, we can do it. But for many games, that's actually not meaningful. It might be, actually, if someone's having really high packet loss or 20 milliseconds or more, yeah, that's worth it, right? So we work with every game customer we work with, and we the first thing we do is we pretty much ask them, what improvement is meaningful for you, right? Like, what is the range of network performance that is okay, and when we can help take something that's not okay and turn it to okay. What percentage of your player base is that going to apply to? And that's it's challenging because people don't really understand how bad it is for a certain percentage of players in their game. It's those people in the forum that are kind of complaining, hey, Friday night at 7 p.m., I had lag for 5 minutes, right? Or sometimes we see for a given data center where they're hosting servers, there's just something going on in Europe for 3 days straight. And we've seen it. We've seen situations where people just have, everyone in Europe suddenly gets an extra 200 milliseconds of latency for 3 days. Right? This doesn't make sense. But this happens often, right? So a lot of people, you might be wondering, are these people complaining about my game for real? Probably yes, right? Because we have the data that shows that these events are real. They happen, and you can't really do much about it unless you use Network Next.
Did you know before building this that it would be successful?
From my past experience, I kind of had a gut feeling because I kind of knew there wasn't much more that I could do to make the netcode on Titanfall 1 and 2 any better than it was, right? We kind of felt that we were getting diminishing returns. And on God of War Ascension as well, it's okay, the bandwidth usage is minimal, the protocol is very latency tolerant, but a significant percentage of players still having a bad experience. And the lesson from God of War Ascension was peer-to-peer is a dumpster fire. Don't do that, right? That was the learning there. So it was really interesting to go to a very client-server, dedicated server team and transition from being peer-to-peer is amazing, it's not, right, to dedicated servers, client servers, and to see that transition as it occurred, and then to realize, even with dedicated servers in the best hosting companies in the world, that's not a guarantee of good network performance for every player, everywhere in the world, all the time, right? We've seen multiple companies, multiple customers we work with have 4 or 5 different hosting companies that they use at the same time. And they end up just playing a whack-a-mole where hosting company A has really good performance now, hosting company B doesn't. What do? Do you migrate your servers around on a daily basis. It's just crazy. So we've sort of seen that, like, game developers, when they hit a certain level of success, can get frustrated with server hosting companies, but that the server hosting companies aren't really at fault. Sometimes it's not even the player's ISP that's at fault. It's the things that are in between. If you do a trace route from your client to your server, the route that you're taking is sometimes the problem. And the hosting company, the game developer, and the ISP are not fully in control of that route on the internet. And there's not really any guarantee that that route will be the lowest latency, lowest packet loss route for you. So we hop in there and make it that.
Got it. And Glenn, isn't League of Legends, is that peer-to-peer from a Netcode?
I don't have a lot of insider knowledge for that. I believe they're client server.
Okay.
I would be really surprised if a competitive esport was peer-to-peer just for security reasons. But it's a game that's been around for a long time, and what many people don't know is just like there's a reason why a lot of AAA folks don't talk about their netcode. It's just because they're kind of slightly embarrassed about it. You know, because you got stuff to do. You do hacks, and then 5 years later, you're like, that wasn't the best idea, right? So maybe there's some peer-to-peer elements in there, but I know they have servers. Like there's no perfect netcode out there. It's just a series of compromises and hacks.
All right, guys. So I have one last question. So in terms of like anything emerging as far as trends or technologies that can impact netcode or mobile specifically, what's coming up? Is there anything that we should be aware of, or are we pretty much where we are? And maybe starting with you, Chris.
Okay, I try. I think game streaming is becoming a thing again, maybe the fourth or the fifth time now. It's coming again every year. So it's interesting to see, right? So is this finally happening? And then you see the devices are getting super strong. So with Apple building these crazy chips into the phones and graphics cards and everything. So you have to balance between these high-end phones, which can do pretty much console-like rendering, and on the other side you have the countries which have more the low-end Android phones, and you have to balance your game. So between those, I see more and more visual programming stuff, right? Unity bought this company Bolt, which is similar or the same name as our product, but not related, of course. Unreal Engine with blueprints. I see a trend in WebGL, so more and more games using the browser and WebGL as a host. So it's coming from the casual market, right? So what and Facebook and these casual games are getting very strong. So these are let's say the emerging trends I see, or of course augmented reality, but it's not really of big use yet.
Right. And Chris, I also saw the announcement that I guess via GeForce Now, you'll be able to play Fortnite in Safari. Now, is there any, from your perspective, will you be able to play just as well as, you know, in a mobile app or regularly, or do you see any problems there?
What you mean with game streaming?
Not with games streaming, but you mentioned stuff going to the browser and kind of WebGL and stuff like that. Is that what you were talking about?
Oh yeah, I see. That's pretty. Yeah, I think it's games particular built for that. So Snap purchased a couple of companies and then just focusing on making games just inside Snap, all based on WebGL and 3D, and you have with WebRTC, you basically have UDP in the web browser now. So you have all the good stuff, and you have the browser is becoming an operating system, and there's almost no limitations, right? So it's becoming more and more powerful. So it's interesting, and the only thing you need is a URL, and then you're able to play. So this is the viral effect is extreme there. It's not yet there, right? It's for simple games, and Facebook and so on are pushing it.
Okay.
But Apple, of course, wants to control the ecosystem with the app stores and so on.
Right. Cool. Avinash, what do you think?
So I think we were talking about trends. So one thing I always think about any new trend, for example, 5G, like it will definitely improve the internet speed. But for game developers, we have to always make sure that if our audience is not 100% there in that new trend or new platform, then we have to build for whatever is most common right now. The same analogy is like, now we have really good smartphones. We have iPhone 12, really good smartphones on Android side as well. But we always optimize for the medium level or low end devices even today. So whether 5G comes or whatever tech comes, unless most of our user base is there, we have to like still do the things the way we are doing things now. Like the same optimization, same challenges are going to be there. In terms of new trends, I recently heard Apple's new announcement about that chip, where you can run your iOS games or iOS apps on MacBook. So I think that will broaden up the market more. So like if you are building games for iPhone now, actually MacBook users will also be able to play your game. So Mac itself was not considered a gaming device, gaming laptop so far, but this kind of opens up a new market. So I feel like that is kind of positive for developers.
Got it. Glenn, final thoughts?
Well, I think we're all staying at home. And, like a year ago, I would have said there's two types of games that I see. That there's the location-based games where you play with people around you and games where you play at distance. And I almost wonder if the first category is going to go bye-bye for another year or so, but I do still think it's the case. So from this point of view, I think sort of edge compute and the ability to have compute power that's secure, close to where your game is occurring, could be very interesting. And then for other sorts of games, connectivity across distance, so regional-based esports are a trend that's playing out right now, and more games are creating things that are more like sports and less like games. So I sort of see it splitting into a casual location-based gaming and more casual and more competitive sports-like regional connectivity for player game. And of course, the best example of that would be regional play for League of Legends.
Got it.
But I don't know if anyone's playing people out on the street for a few more months, unfortunately.
Right. All right. Well, guys, thank you very much for your time. I definitely enjoyed this discussion. And for me, it was very, very helpful to get all the different perspectives and thoughts. So thank you very much for your time, guys. And unless there's anything else, I think that's it. Thank you.
Thanks for having me.
All right.
Cheers.
Bye.
Bye.